Okay, time to start using some real database values instead of our hard-coded John Doe stations. For this, we're going to make use of Diesel. Like we already mentioned in the introduction of this course, Diesel is an ORM and it will help us with translating database entries into Rust data types. So yeah, it will do the heavy lifting, and then for us, we will just need to code the logic that connects our endpoints to the database and nothing more. To start using Diesel, we will need to install its CLI tool. It is a tool that will help us with generating migrations and also setting up our database initially. It is a tool that we will install globally, so it is not a dependency on our package, so we will not put anything in here for now. For the CLI tool, we just need to install it on the host machine that runs our application. Also, of course, on our local environment, or basically wherever we are going to host our application, this Diesel CLI tool needs to be there in order to run migrations and so on. So the way to install this tool, this CLI tool, is using cargo, like always. So cargo install Diesel CLI. This is how this tool is called, Diesel CLI. This will download this project, compile it, and store it in our somewhere in our system, so it is accessible then from now on with just the Diesel command. So this command will touch nothing in our project in here. It is something that will run globally. Before doing so, I'm gonna pass some additional flags to Cargo, because I don't want Cargo to install support for Diesel for all major databases. Diesel CLI by default will come with Postgres and MySQL support enabled, but I don't really need that. I will only specify support for SQLite, since SQLite will be the database that I will use now, mainly because setting it up is a lot easier, hassle-free. Setting up a MySQL or Postgres database locally probably is something more complex, so I will stick with SQLite, which in the end is just a simple file. In the end, everything is stored in a simple file, and I don't need to bother more than that. For you, it doesn't really matter. You can choose any database that you need. Actually, this is the point of using an ORM. We're using an ORM so that we remain database agnostic. You can use the same program with different database engines in theory. So yeah, feel free to choose your engine. For the purpose of this tutorial, I'm going to continue with SQLite. And before going on, one more thingy. For your local environment, installing support for any of these other databases requires for your local host system to have some additional libraries. This really depends on your operating system and the database backend that you will choose. For example, for the Postgres database, you will need libpq. For MySQL, libmysql client. For SQLite, you're going to need a libSQLite 3. You can find info for this on the Diesel official website. For SQLite specifically, I would like to mention that if you're on Mac OS, probably you don't need to do anything. It comes pre-installed as far as I know. For Debian-based operating systems, like I have right now, you will need this libsqlite 3-dev, so it is something like this. You will need to install it by typing it lib SQLite 3 SQLite, I forgot the Q, libsqlite 3-dev. This should work. For me, of course, it is already installed, nothing to do here. So I will go ahead and run the command now that installs Diesel CLI. I have it here. Oh, there you go. Ready. Cargo install Diesel CLI. No default features because I don't want Postgres or MySQL support. And then enabling just the SQLite feature. This will now download this tool, compile it, and make it globally available on my system. From after the installation is done, I will be able to access this tool just by typing Diesel. You see here that it has quite a few dependencies that take some time to compile, like 84 dependencies, and yeah, CIRD is one of them, as you can see. If you remember correctly, CIRD is the serialized and unserialized crate that we used for JSON support. So Diesel uses CIRD as well. Makes sense. It needs to map data from one system to another, decoding and encoding, serializing and serializing is involved here definitely and heavily. Okay, and we are almost here. So you see, this Diesel binary was installed in my home folder. That means if I type Diesel here, there we go. I can access this command and I can access it from anywhere, basically. And yeah, we have now the tool locally, it is working, and we are ready to start setting up our database. So, in order to set up our database, we will just need to type Diesel setup. There you go. So we have this setup subcommand, which will create the migrations directory. This is where we are going to have all of our migrations stored in the end. And then it will also create the database specified in the database URL. To specify where the database is going to be, we can also do it with this argument here, database URL. And then we can call our database database.sqlite, and we're gonna store it in the same directory here. SQLite is that simple. I can just specify the location of each file, and then there we go, we have it there. No need for any username or password or authentication at all. Yeah, it's fairly simple. There we go. Now see, this now command generated this file, database.sqlite, which is essentially our database. Simple as that. That's why I love SQLite. It's very easy to work with it for non-serious application, of course. And then we also have a couple of more files. Okay, one is the migrations directory, which is the directory that we're going to be putting our migrations from now on. But then we also have this diesel.toml file, which is basically configuration for Diesel. Yeah, you can see here we can configure where the migrations directory is, because in theory this is configurable. We can have another directory with some other name, but we're gonna stick with the default one, it's fine. And then we have another configuration value, which is print schema, which I will explain later how it works. But for now, we just see that we have a configuration option here of where this file should be, which by default is under src. Okay, then now we are ready to start creating our first migration. Basically the migration for our Rastasians. We want to make a table that is going to hold our Rastasians records. And the way to do so is by using our Diesel CLI tool again, but this time we're going to use another subcommand. We're going to use migration subcommand. And if we type Diesel migration, we get several further subcommands of the subcommand. It's like a help output here, which gives us like all the possible options. We can generate a new one, and we can list all available migrations. We can just list pending migrations. We can redo migrations, revert migrations, or run. For now, we will use the generate one, and then after generate, we are gonna need to specify the name of our migrations. For this specific migration, we just want to create the Rastasians table, so let's call it create Rastasians. And now we have two files generated up and down SQL in a folder which has the name of the migration. So this is why it's a good idea to use descriptive names for your migrations. So afterwards, just by opening the migrations folder, you can see what each directory is about. You see the directory name, and then you immediately know what this migration is about. So yeah, be as descriptive as possible in here. It's gonna save some time for you down in the line. So we have two files, up and down SQL. Up.sql is basically the SQL that we will run that creates our table. So when the migration is run, it is going to create this Rastasians table, and this Rastasians table creates like 4 columns in it: ID, name, email, and created at being a timestamp. ID is auto increment, primary key, name and email, of course, just varchar columns that contain the name and the email respectively. What else? And that should be it. And now for the down.sql, we just basically need to undo whatever the up.sql did. So if we ever decide to revert the migration, it will be correctly reverted. And then, of course, yeah, see this comment here also explains it. This file should not do anything in app.sql. So whatever app.sql did, we should undo it. And this is very easily done by drop table statement. And the table name is Rastasians. We don't need to have semicolon here. This should run. So let's try the list command now to see if it will properly list our migration. Okay, we need to pass the database URL because, of course, Diesel needs to know which database to look into, because we might have, I don't know, maybe several databases. Okay, there we go. Now we have this migration listed, and you see there is nothing in here. This is not checked, which means that this migration hasn't run, and we're gonna go ahead and run it by using the run subcommand. Instead of list, we're gonna use run. Okay, now the migration was executed. Let's run list again. There we go. See, now we have this X letter here, which indicates that our migration is properly run. And it's also a good idea for the first time that you run the migration also to test the revert path. So you know that if at some point you need to revert the migration, the revert path will work. So let's try to revert it. And there you go, rolling back migration. Our migration was successfully reverted. So let's list it also again out of curiosity. All good. And then let's finally run it. Okay, so our first migration is here. We ran it successfully. But what do we have here? We have the schema rs file. This was generated right when our migration was run. And in here we have basically a call to the Diesel macro. And then this call will basically try to represent or describe this REST async table that we created as a Rust data type. So this macro will translate this into a Rust data type. And then we will be able to query our table and so on. Basically, we'll be able to interact with this table thanks to this macro. Yeah, that should be it for now. Let's move on with creating our model.